Hamish. I work as a data scientist at a company called Elliptic. Elliptic's one of the one of the main blockchain analytic companies that's out there at the moment. It's been around since 2013. It's our 10-year anniversary this year. And basically, yeah, we're all about blockchain analytics. Specifically, we're interested in finding illicit activity, and I'll talk in a bit more detail into kind of how we build a business model around detecting illicit activity. So to take a step back and just think, what are we looking at when it comes to blockchains? Well, at a real fundamental level, blockchains are public ledgers. So what does that mean? It basically means we have a list of transactions that are happening over time between different entities. So here we've got some transaction between entity A and entity B, some value, it's at some certain time point. And all that a blockchain is a series of movements of the funds on the network between these different entities, these different addresses. And what we can do with all of these transactions in the ledger is we can construct what we call a graph, which is a representation of all of the flows between all of the different entities in the network. So in the case of Bitcoin, we can think about addresses being the places where funds can be stored, and then transactions between these addresses we refer to as the edges of the graph. So in this example, you can see 10 Bitcoins being sent from entity A to entity B, and then we've got that being split into 3 Bitcoin going to entity C and 7 to entity D. You kind of get the point, and you expand this to the entire blockchain, and you have this huge transaction history of everything that's ever happened in the entire history of the blockchain. And this becomes more interesting if we start to think about maybe we might know which entities control which addresses in the network. And then we can say, okay, say for example, we are entity G, and we might know who entity B is, and that might be of interest to us because it means that some of the funds that have been sent to us from entity C originated from entity B, and that might be of interest to us. This is quite an abstract example, but I'll kind of make it more concrete further on. But this is kind of the point of this whole idea of this transaction graph and what you can do with it. So taking a step to one side and just thinking a bit about, okay, it's all well and good having these blockchains with really open and transparent transaction ledgers, and we can do analytics on them, but kind of how can we build a business model around being able to do some kind of analytics on the blockchain? Well, here's a screenshot from a famous darknet market, the original darknet market called the Silk Road. And the Silk Road has got quite an interesting history. It was kind of created as a libertarian project, and the idea was there should be freedom for anyone to buy whatever they want, and they should be able to do it anonymously if they want to. And yeah, long story short, basically, the Silk Road was eventually shut down in 2013. But ever since then, darknet markets have always been reappearing in different forms and different disguises. And yeah, this is of interest to people because Bitcoin was one of the key enablers for Silk Road back in the day. Like the previous problem with building a darknet market was how would you transact on that market? And Bitcoin was a good solution to that problem, because it provided a way to transact without directly showing your identity. So it made people more comfortable buying things. But there's another side to the story, which is there's also a lot of hacking that happens in the world of cryptocurrency. It's been a lot in the news recently, and particularly of interest is there's perpetrators in North Korea known as the Lazarus Group. That essentially Kim Jong-un has been building what's believed to be sort of an army of hackers, and they've been trying to steal as much money as they can. And they've recently been really focusing in on trying to take money from things like DeFi projects, exploiting them. And countries like the US are very, they engage in essentially what is economic warfare, and they try to do everything they can to prevent the North Korean regime from funding things like their nuclear program. And so what the US has done is it does things like it sanctions entities. And there's basically this body in the US which says that there are certain entities that you can't transact with if you're, I can't remember the exact details, but it's if you're an American company, certainly you're obliged to be not transacting with any sanctioned entity. And this poses the question to anyone that's using cryptocurrencies. If people like North Korea are controlling some of the funds in cryptocurrency, how can you know if some funds come into your platform? How can you answer the question, did these funds come from North Korea, or did they come from illegally sourced funds from a darknet market, for example? If you want to hear a bit more and learn a bit more about these North Korean hackers, there's a really interesting podcast and book. I think the second series is just about to come out, called The Lazarus Heist, which I'd recommend listening to if you want to hear a little bit more about. It's very fascinating. So yeah, I mentioned this entity, OFAC, is this American sanctioning entity. And here you can see just the size of some of the, essentially the way that OFAC does its sort of enforcement of ensuring that people comply with these sanctions is they'll fine companies, or they'll, and these are a bunch of fines that have been handed out over the recent years in different jurisdictions. And you can see that this can be of real concern, particularly to big companies. So taking a step back to the transaction graph, if you're, say you're a big exchange and you're servicing deposits of cryptocurrency, the question you want to ask, you want to be as confident as you can that you're not receiving funds from these illegal sources. And so if we can start to label entities inside the blockchain, then we can start to trace backwards from whatever deposit you're receiving in your exchange, and you can see where those funds have come from. So you can do things like what's happening here. We can see that this exchange, so here is the Lazarus Group, which is this pseudonym for the North Korean hackers. And here what's happened is they've directly tried to cash out 1 Bitcoin via an exchange and convert it into fiat currency so that they can make use of it. And that exchange wants to do everything they can to, well, if they want to be compliant and avoid receiving any sort of fines from sanctions violation, they want to be aware where these funds have come from and if they've come from something like a sanctioned entity. So how do we answer this question? We can trace back in the graph and we can say, okay, this transaction came from the Lazarus Group. So maybe we want to isolate those funds and make some kind of suspicious activity report and tell the law enforcement agents about it, or whatever your process is. But there's also a bunch of other things to consider. Different companies have different requirements in terms of risk. Like some companies might be more concerned about funds from darknet markets, for example, than others. And part of what we do at Elliptic is we basically see ourselves as a data vendor. We give information to our customers, but we don't prescribe any sort of, we don't decide like what is kind of good and what is bad in the space of blockchain. It's basically onto our customers to decide what funds from what sources they're not comfortable in handling. So you can do things like you can configure, if you might not be happy receiving funds from a darknet market, but you might be okay with receiving funds that come from a gambling source, for example, whereas other places like in the US where gambling is illegal in some states, they might be less comfortable receiving funds from a gambling source, for example. And these are the kind of things that we can do analysis on the blockchain to give information to people when they're screening things like transactions. But then there's always this question of when we go back to maybe the darknet market and people were comfortable using that darknet market because supposedly Bitcoin is this anonymous or pseudonymous network. So this is a screenshot from the Block Explorer. Hopefully some of you maybe seen this before. But essentially this is just a visualization of a particular transaction. And if you were to look at this particular transaction, you wouldn't have any clue that I was the person that sent this transaction because there's none of my personal information in this transaction. Everything's broken down to these addresses, which are these. So this is an example of an address that someone sent funds from. And so we don't know who controls what addresses. And it's kind of like phone numbers. If you were to just see a random selection of phone numbers, you wouldn't really be able to tell like who controls those phone numbers. So what can we do about that? Well, it turns out if you're operating a service, then you need to provide some kind of information, an address, to be able to give people somewhere to deposit their funds, to pay you for your service. And it means that if you search the internet, you can find out. So say you were to go onto a darknet market, for example, like the first thing that a darknet market will probably ask you to do is to deposit some Bitcoin with them so that you can buy things. And they're gonna have to give you a Bitcoin address to deposit that Bitcoin. And that means that we now have a piece of information. We know that they control that particular Bitcoin address. Here's another example of a service where you can donate Bitcoin. This is for the Ross Ulbricht, the guy who created Silk Road. This is kind of a charity thing for trying to pay for his legal fees. But here you can see they've listed the Bitcoin address if you wanted to send some Bitcoin to help a cause. So then there's this other question of, in theory, if you're using Bitcoin really well, you're supposed to only use addresses once. Like this is kind of seen as like good address hygiene. But often we come to difficulties with that because in Bitcoin, Bitcoin operates a bit like a cash system of coins and notes. Everything, when you kind of collect, say you're a service and you're collecting money from lots of users, what will happen is you'll collect loads of coins and notes. And eventually, even if you were to deposit all those coins and notes in separate addresses, an onlooker would think, okay, like none of these addresses are connected in any way. But at some point when they want to go and use those funds, they'll need to consolidate them the same way that if you were you were a shop collecting coins and notes, eventually if you wanted to go and buy something new, you might have to take all your like £1 coins and put 10 of them together to go and buy something else. So that's what we call like consolidation of funds. And we start to see consolidation patterns in the blockchain where funds are being brought together and you start to see connections between what might have previously looked like isolated parts of the blockchain. And this is an example, continuing with this free Ross Ulbricht address. If you go into a block explorer and you have a look at, you can see, because the blockchain is transparent, all of the deposit transactions that have happened to that address that I showed earlier. And you look at it, and every now and then, all those individual deposits are consolidated and forwarded on to pay for some kind of service. And what happens is they'll connect many of the addresses together as they use each of those chunks of coins to pay for some service. And that allows us to infer that all of these individual, what might have originally looked like individual users, is actually one single actor on the blockchain. So this is a bit of a visualization of what's going on here. It's known as the common spend heuristic, and it's one of the most important kind of, this is like open published. I think it was published by a PhD student originally. But it's one of the key methodologies that's done for kind of unraveling what's happening on the Bitcoin blockchain and understanding that even though we have this very vast address space, you can actually infer clusters of these addresses which are spending together. And you can infer, for example, if you were to look at and find a really large cluster, you probably have decent chance, like it'd be a decent chance it would be an exchange that would be operating, because they're going to be doing loads of deposits and withdrawals constantly. They're going to be consuming loads of addresses. So what can we do about the fact that companies like Elliptic can spy on us and work out what's happening on the blockchain? So there are a couple of techniques that you can use to maximize privacy. One of which is you can use this technology called coin joins, and basically it tries to kind of fool this previous methodology that I was talking about. And the idea is that you coordinate with other people when you're spending your Bitcoin, and you spend them together in a single transaction, even though you're different entities trying to do different things. And it makes the blockchain analytics companies think, okay, so this is a single entity, when in fact it's multiple entities coordinating together. And this is a bit of a visualization of a coin join. Like one way of thinking about what happens with a coin join is if you imagine there are 10 people and each of them wants to spend £10, but they don't want to make it clear who they're sending the £10 note to, what everyone could do is everyone could put their £10 note into a hat, and they could all withdraw another £10 note from the same hat, and you wouldn't be able to trace through if you didn't have those connections between those notes. And suddenly we've broken the link of being able to trace through the graph and understand where those funds have been. The problem with this is it's hard to coordinate with other people. Like previously, like back in the day, there would have been, early in the days of Bitcoin, there would have been forums where people might have directly contacted someone and said, I really want to coin join with you and consolidate our two transaction histories together and try and obfuscate what I've been doing. But over time, there's been a couple of implementations of this coin join using software. And these are designed to be cryptographically secure self-custody solutions, so you don't need to trust a third party. So in the instance when I gave the example of the hat, the problem is what happens if that hat is controlled by some third party and they suddenly disappear with the hat before you have time to withdraw it. So Wasabi Wallet is an example of an implementation of CoinJoin that you can use. And it's pretty interesting to give it a go. You can just, I think Wasabi is an example of one that you can only run on a desktop. But basically you can see that you have a bunch of different kind of configurations that you can do to different strategies for doing your coin join. So you can do things like you can maximize privacy, and what that will do is it will take longer for your transaction to complete, because it's going to wait around trying to coin join with as many people as possible. It might even do multiple coin joins. You'll end up paying quite a lot in fees, but it allows you to obfuscate your activity as much as possible. Another interesting feature that you can be aware of when using Bitcoin is if you go onto Blockchair, the block explorer I've been using, they have this interesting feature where you can see the kind of privacy level of every Bitcoin transaction. It gives a scoring. This gives some suggestions for the kind of things that you should do to try and obfuscate your activity as much as possible. So they've got examples like use Bitcoin mixers, which is essentially another word for coin joins. But also do things like don't send round numbers, avoid reusing your wallets, and avoid using many of your addresses in the same transaction. But these are the kind of things you can think about when trying to obfuscate your activity using Bitcoin. That's the end of my presentation.